Solution to a 3-mark question that appeared as part of the sample paper given by CBSE in 2019 for Class 10 Math. Question number 21. This question had two alternatives. Both alternatives appeared from this topic, surface area and volumes. We got solution for both these alternatives in this video. Let's get started. The first one. Water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeters. Diameter of the pipe is given into a rectangular tank which is 50 meters long and 44 meters wide. Find the time in which the level of water in the tank will rise by 21 centimeters. So in this question, there's something that's given in kilometer per hour, the rate. The diameter is given in centimeters. The length and width of the tank is given in meters. And the height to which the water rises is given in centimeters. So we have a mix of units, some centimeters, some meters, some kilometers. As a first step, let's make all these units uniform. Let's make the measurement of length to be a meter for all these cases. If 15 km per hour, each kilometer is equal to 1000 meters. So 15 km per hour is converted as 15,000 meters per hour. Diameter is 14. We'll need the radius more often than not. So radius is half that, which is 7 centimeters. Centimeter to meter conversion, a centimeter is 1/100th of a meter. So it's 7 by 100 meters. These two measurements are given in meters. We're not going to do anything about it. Lastly, the height to which water increases is 21 centimeters. We'll rewrite it as 21 by 100 meters. So in this step, we've converted the units of all measurements into meters. So move on. Step 2, what we're going to do is we're going to find out the volume of water that flows through this pipe in 1 hour, in each hour, in unit time, how much of water is flowing through this pipe. How do we find out the rate at which water is flowing into the area of the cross section of the pipe through which it is flowing? The rate at which water is flowing is given as 15 km per hour, which we converted it as a 15,000 meter per hour into area of the cross section of the pipe. The diameter of the pipe is given. So the cross sectional area is going to be a circular cross section. So that's going to be equal to pi r square. Let's take pi to be 22 by 7 and the radius is 7 centimeters, rewritten as 7 by 100 meters. So we'll get all things in terms of meters. So 15,000 meters per hour. So let's take it as 15,000 into 22 by 7, which is the value for pi, into r square. R is equal to 7 by 100. 7 centimeters, which is 7 by 100 meters, into a 7 by 100. Right, the 3 zeros here will cancel with 2 zeros here and 1 more 0 here. Let's cancel the 7 with the 7 here. 15 into 22 is a 330. So we have 330 into 7 divided by 10. These two will get cancelled to leave us with 33 into 7. 30 into 7 is 210 plus another 21. So the volume of water that's flowing through this pipe in 1 hour is equal to 231 meter cube of water is flowing per hour through this pipe. Quickly summarize this, recap it in a printed form. The rate of flow into area of the cross section will give us a volume of water flowing each hour. Plug in the values 15,000 meter per hour into pi r square. Substitute values of pi as 22 by 7 and radius as 7 by 100. We get 231 meter cube per hour of water flowing through this pipe each hour. Let's find out in step 2 how much of water has gotten into the tank when the level of water in the tank rises by 21 centimeters. Right. So that is going to be equal to the length into width into height. Basically, it's a rectangular cuboid. So length into width into height will give us the volume. Length we know is 50 meters. Width we know is 44 meters. The height to which water increases, the level by which water rises is 21 centimeters. So let's write it in terms of meters, which is 21 by 100. Meter into meter into meter. The measurement will finally be equal to meter cube. So much of water, the volume of water that has gotten into the tank when its level rises by 21 centimeters is basically so many meter cube. The 50 will cancel with 100 to leave us with a 2. 2 will cancel with 44 to leave us with a 22. 22 into 21 is basically equal to 462 meter cube. So how much of water has got added into the tank? The amount of water that's got added into the tank is equal to 462 meter cube. Summarize it in a printed form. We got this answer here. Now, 462 meter cube of water has come into the tank through a pipe that fills at the rate of 231 meter cube per hour. How long is it going to take? That is what the question is, right? How much of water has gotten into the tank? 462 meter cube. At what rate is this pipe filling? It is filling 231 meter cube per hour. How many hours is it going to take to fill 462 at the rate of 231? It's going to take us 2 hours, right? This is done. Let's move on to the second alternative. Second alternative is also from the same topic, surface areas and spheres. Here we are going to be talking about volumes of spheres. A solid sphere of radius 3 centimeters is melted and then recast into small spherical balls, each of diameter 0.6. Here the radius of the solid sphere is given. It's converted into balls whose diameter is 0.6. We need to compute the number of balls. How do we find out? The number of balls is equal to volume of the solid sphere divided by volume of each of those spherical balls. Both of these are spheres, so the volume is given by the formula 4 by 3 pi r cube, where r is the radius. Radius of the sphere, solid sphere, is 3 centimeters, directly given to us. Diameter of the balls is given, which is 0.6. So convert it into radius, which is equal to 0.3 centimeters. Units, all units are in centimeters, so no conversion is warranted. Step 1, let's find out the volume of the solid sphere. Volume of the solid sphere is equal to 4 by 3. Let's retain pi as pi because we're going to have 4 by 3 pi coming for each of the spherical ball also. So let's not even try to evaluate this. Into the radius is 3 into 3 into 3. Don't bother writing it as a 27. This will cancel out with a 0.3 in the denominator subsequently. Volume of each spherical ball is equal to the same 4 by 3 into pi. The radius in this case is equal to 0.3 into 0.3 into 0.3. Just ensure that you did not make the mistake of writing it as a 0.6. Right. So we have found out the volume of the solid sphere. We have found out the volume of each of the spherical balls. Number of balls, we wrote it in the first slide, is basically dividing the second term by the first term. The volume of the solid sphere divided by volume of each of these balls will give us a number of balls. 4 by 3 pi will get cancelled. 3 by 0.3 is a 10. So that's going to happen for each of these 3 by 0.3. Each of the 3 by 0.3 will leave us with a 10, 10 and 10. So that's going to leave us with 10 into 10 into 10, which is equal to 1000 balls. So how many balls will we get by recasting the solid sphere? We'll get 1000 balls. Do you have a preference between the first alternative and which alternative I would choose to do? Second one is definitely easier than the first one. So if I have to choose between the two, I'll go with alternative 2. Before you leave, do 2 things. One, sign up at online.maxtute.com for CBSE coaching for class 10 math, online coaching for class 10 math. Takes all of 3 steps and less than 5 minutes to get started. And lastly, subscribe to this channel, youtube.com/maxtute, and spread the word among your classmates and friends.